Cisco instructor Andrea here, and I wanted to go over this assignment, route lookup best path. Description, determine the route a packet will take. This is referencing the way that the router works in order to get a packet to its destination. Whenever a packet leaves the end device, or a frame leaves the end device, it's going to go through the switch, and then it's going to head up to the router. And what it's going to do is it's going to hit the interface on the router, and then it's going to de-encapsulate that, and it's going to look inside to find the destination IP address. The next thing that's going to happen is it's going to consult its route table, and it's going to see if it has a destination network in the route table. What it's doing is it's looking at the destination IP address, and it compares it to each of these networks. And it asks itself, or it does a little calculation by comparing the leftmost matching bits to determine which of these routes is the best route. Sometimes there's more than one route to a destination. It wants to take the best route. This assignment is to get some practice on learning how to determine the best route. You're going to be thinking like a router. So let's take a look here. Let's take a look at an example. This question right here matches my sample. This packet is destined for an IP address of 172.16.0.10. The first thing I'm going to do is I'm just going to go ahead and I'm going to plug in the destination IP address into my table. And then I can see in the route table, these would be my different options. I've got those plugged in as well. One thing to notice when you're figuring out routes is this first octet, everything matches. I know I've got all of those on the left that match. The next thing I have to do is look at each individual octet based on the subnet mask. For route number 1, we're only looking at 12 bits. I'm going to bit 172.16 out, and then I'm going to bit out, and I'm going to compare it to my destination IP address. So notice everything in octet 1, that is a match. Everything in octet 2 is a match. So I know that route 1 would work. As of right now, all of the left bits match up to a /12. So that's good to go. I need to know, does the next one work, and are there more matches? I'm going to look at route 2. Now here, this network has 18 bits. We're going to compare 18 bits. I already know that the first 8 match. Now, let's look here. The next octet, I can see here that the next 8 match as well. And then I've got to get out to the 18th bit, which puts me in octet 3. And this is a 0 and a 0, and that matches. As of right now, route 1 is no longer the best match because route 2 offers 18 bits that match. Now, route 2 is my best route. Let's take a look at route 3. Here, I'm going to be comparing 26 bits. We know that the first octet matches. We know that the second octet matches. Well, let's take a look at 3. Now, I do know, I can see right here that they match. So all of my zeros, this matches. I've got to go out to the 26th bit. I've got a 0 and a 0 in my IP address, and I compare that to the 25th and 26th bit, and it matches. Sure enough, route 3 is my best match. That will be my answer right here. Route 3 is the best match. Okay, let's do another one. I'm going to plug in this IP address, 172.15.0 and 2. It doesn't matter what the prefix length is for the destination IP address. What routes do I have available? I've got those same routes available here, and it's going to be a /12, /18, and a /26. And let's not forget our default static route because we may need a default static route at some point. I'm just going to bit these out. Okay, let's take a look at this one. My destination IP address is 172.15.0.10. I've already plugged in my IP address 172.15.0.10, and I went ahead and I bit it out. Now I've got to start some comparisons. I can see here that octet number 1, everything is a match. I've got to look at this octet number 2 though, because here we've got 15. Okay, I've got the 15, and I bit that out right here. And I need to compare this IP address bits to the bits in the network up to the 12th bit. I have 8, 9, 10, 11, 12. So right here, I'm comparing these to my IP address. Now I'm thinking you might already have noticed what I've noticed. This matches, but right here, I've got a mismatch from here to here. There is a mismatch. This route will not work because the minute there is a mismatch, game over. That route won't work. And you can see that's going to be the same for all of these. Because this is a 15, it automatically quits matching. What does that mean? That means that my default static route right here, route 4, that is going to be the only option that works for this packet. Our answer here is our default static route. Let's do one more. I want to make sure that everyone understands that you don't automatically assume that the network with the most network bits is going to match. It seems like that at first, but let's do this one right here. We've got 172.16.129.2. I've already plugged that in right here. I've done all of the bits. And let's just take a look. We're going to start out by comparing it to the first route, where we're looking at the first 12 bits, and we can see that is a match. Good job. So route 1 for sure we know is a match. Let's go ahead and compare it to our next option, route number 2, where we're looking at 18 bits. Okay, so I'm going to go, let's see, there's 16, there's 17 and 18. Let's just come and highlight this. I'll make this a little bit different color. Okay, first octet, that is a match. Good job. Second octet, that is a match. Look at this though. Right here, the 1 is turned on in my IP address, and yet it isn't turned, the 128 position is turned on, but the 128 position is not turned on in my /18. So route 2, even though it is a longer network, it doesn't work. Right now, I'm still looking at this route, route 1, as being our best route. The same thing is going to happen with /26, because right here on the 17th bit of the IP address, I get a mismatch. Route 3 doesn't work. I don't need the default static route because route 1 works. So in this situation, the shortest route or the shortest network is actually the best route. I hope this helps. Go ahead and work on the longest match. And if you need more help, send me a Canvas message.